Okay, thank you, Mikael. So hi everybody, my name is Manuel. I work for CSCS as a system engineer. And today I'm gonna try to present you a tool that me and other colleagues have been working on in order to manage CSM clusters in Alps. This tool is called Manta, and then we're also going to talk about some internals and environment in which this tool works. My idea is to do like, I don't know, 20, half an hour slides. If it's less, even better. I will try to make the slides as short as possible. And then I will try to do a live demo, okay? So you can have a better impression about how this works and have something more tangible to think of. Okay, so let's start then. So this is summary. I'm going to start talking about the CSM, which is the Credit System Management, which is the set of tools in Alps that Manta talks to. Basically, when we talk about Alps, Alps has two parts. One is the compute part. The other one is the management part. The management part is basically a set of microservices orchestrated by Kubernetes, and it exposes some APIs in order to do operations on your clusters. Okay, so a few concepts. Within CSM, we have, this slide better. So these are basically the terminology I will go on and off during the talk, and these are terms that are heavily used in CSM. Okay, so these are the terminology I was talking. I'm going through on and off between these terms, so I better first off give you a definition of what they mean, so you are in context. So we have the HSM groups, which basically we can call it as a cluster. It's as simple as thinking of them as a group of compute nodes, okay? And in HSM, we refer a compute node as an X name, which I will explain later. Now we have the CFS, and the CFS has two parts. One is the configuration part, and the other one is the session. The configuration is basically a schema or a recipe of how you want your cluster to look like. So with CFS configuration, basically you shape the images that are going to be booted on the compute nodes, and also how the nodes needs to be configuring after booting. The reason it works like this is because we cannot put everything in one go. So for example, stuff like mounting file system or configuring network, you need to do this type of things while the node is already running. So those type of tasks needs to run outside the building configuration job. And last, we have the BOS, which is the boot orchestration service. And what it does is once you have your configuration ready and your images, you basically tell CSM, okay, now I want you to, under this cluster, under this HSM group, I want you to boot the nodes with the image I created based on this configuration. And I also want, after the nodes are booted, to finish the configuration using another CFS configuration. So this is a highly overview of what is going on. So for the hardware state management, I mentioned before X names. So the X names is basically, it's an X name, start with X. And the main goal is to identify the location of specific hardware components inside Alps. So the X name can be as long as defining a specific GPU on a compute node or a DIMM, or a chassis, liquid system, compute nodes, management nodes, etc. And it has two parts. One is the cluster definition, which is a label for the cluster, for example, tenant A, or CSCS test or CSCS production, whatever you want to call it, and the group of nodes that are inside. And then you have the hardware inventory, which basically through the HSM API, you can say, I have these nodes, give me the hardware that are inside. You can do this type of things. Okay, this is now an overview of how the overall system works. This is very high level, okay? So I'm not going into much details. Basically, how this normally works is you have on the left side a user who has an Ansible playbook. The Ansible playbook is going to be used to shape the state of your cluster. So once you have an Ansible playbook you're happy with, you're going to push it into a Git repository. This Git repository is going to get synchronized with the Git repository of Alps. And from there, you submit jobs in order to create CFS sessions or CFS configurations in order to build images or configure nodes. For example, if you see here, you see can you see my mouse, by the way, or not?
Yeah.
Okay, so on the CFS here, if you want to build an image, basically it's going to spawn two containers. One is the one running the Ansible. The other one is going to be a base image that you define that is stored in the Ceph cluster. And once it finishes, it's going to do what I'm calling here a boot image. And then after that, you configure bots in order to allocate which boot image you want to boot each machine. And you do stuff like also changing the configuration to finish configuring the nodes where they are booted, and also calling capmc in order to do the power management of the nodes, like shut them down, restart it, etc. Now, CFS. CFS has 4 key players. One is the Ansible scripts, which I already mentioned. These are your Ansible scripts as a user. And you put your tasks there to install software, copy configuration files, compile stuff, etc. The Ansible layers are used by what is called CFS layers, which is basically a pointer to a repo with an Ansible script. And then we have the CFS configuration, which is a group of layers. And then the session at the end will take the configuration and then apply the job to what you want it to do. Okay, a point about the configuration layer. The configuration layer, again, can use the Ansible tasks in 2 different ways. You can target each task to be run while building the image or configuring the nodes. And you do that by this variable here is called create CFS image. So if this variable is true, if this variable is true, means that the Ansible is running to build an image. And if it's false, it's not building an image, it's configuring a machine. Important here, as of today, we need to make sure that the user-facing Git repo, which is the Git repo that the user is pushing the Ansible scripts, needs to live in a trusted network, okay? Because what he pushes is going to be replicated into Alps. So how a CFS layer looks like? So it's a JSON. This is a simplified version of a CFS layer. There are more fields, but these are the most important ones. You have the URL where your Ansible scripts lives. You have the commit ID, then the name you want to allocate to the layer, and then the playbook, which is the Ansible playbook you want the CFS session to run. So the tasks are, when the CFS session starts, it's going to clone the repo, it's going to check out the commit ID, and then it's going to run Ansible playbook against this site YAML. This is the same with notations. Okay, and the configuration is just a group of CFS layers. They are executed sequentially from top to bottom according to how you define them. They can be used to create images or configure a node. I'm repeating this quite a lot. Configuring images, building images, configure or not, because this is important. And this is how a CFS configuration will look like. Is another JSON with a name and a set of layers. And again, the order these layers are run is from top to bottom. So this is important because if you have a layer that depends on another one, then you need to make sure that you need to be careful with the order. Now, okay, a session is what I'm calling here an instantiation of a CFS configuration because the CFS configuration by itself doesn't do anything. You need to tell Alps and then say, now take the configuration and build the image, or now take the configuration and apply it into a running machine because I want to finish mounting file system or doing other stuff. So the target definition is how you define this. There are two different types. One is the target definition image, and the other one is the target definition configuration. The CFS sessions, as I mentioned before, they run on pods or in containers. They are orchestrated by the Kubernetes living in the management plane of Alps. Each CFS layer runs in a pod, and these are the different steps that they do. Each step runs on a different container. The first one is to be in the Ansible inventory file. The second one, I already explained, it does the git clone, check out to the commit ID. And the last one is run the Ansible script. And then I put 3 dots because I think there is another one, which is another container, which basically will take the image of the container with the image and then create a squashy first and then push it into S3. Okay, so this is how it looks like. If you want to build an image, the yellow squares is a pod. The rhomboids pink, they are containers. And then you have there the Shasta CVS, which is the Shasta Git repo. And you have 2 pods. One pod is to run the CFS session, build inventory, git clone, etc., run the Ansible. And the other one is the target image with the base image you define in your CFS session. This is the same, but to configure a machine. But the difference is the target of the Ansible, instead of being another pod, is going to be a physical machine. Now, boss. So you have your configuration, you have your image, and you also have the configuration to configure the nodes. Now you need your cluster to have the shape you want to. So the way to do this is through, one way to do this is to use the boot orchestration service. By using this service, basically you are going to tell Alps or CSM, I have these clusters with this, I have these nodes that belongs to this cluster, which is a HSM group with name X. And I want these nodes to boot with this image and then finish configuring them and reboot them to apply this new configuration. This is the same thing as I put before. Okay. Now, that was a quick short introduction to CSM for you to understand the environment in which Mesa needs to deal with, or Manta needs to deal with. But before talking to Manta, I'm going to talk about Mesa. So, brief introduction. Mesa is a library that is used to Manta. And the goal of Mesa is first one of the goals is to understand how software-defined infrastructure works. So we have received an infrastructure, and now we need to make sure that we make it, we can use it efficiently. Efficiently means we can operate fast, we can iterate cluster fast, and we are able to we don't need to worry about clusters. We can focus more on the work we want to do. Libraries we are working on, deploying software or infrastructure. So Mesa is a library, okay? It's a library built in Rust, and it's a way for you to programmatically extend and operate on CSM. Some of the things you can do is, for example, you can build a CLI. In this case is Manta. Manta is a CLI that uses Mesa, but you can also build like web servers, HashiCorp providers, etc. And the reason you can do this is because Mesa is built on Rust, which is a programming language that doesn't have a runtime, and it works at low level. So you could, it has bindings for other programming languages like Python or Go because it's compatible with the C APIs. Also, we are in talks with OpenChami. They show interest in order to use Manta as a CLI for them. So that's another goal. If we achieve that, that would be awesome. Also, with Mesa, we are not trying to hide complexity. On Mesa, Mesa will expose the APIs of CSM at different levels. You have low level and high level functions in order to do easy operations. And another of the goals is we want Mesa to be high performance. For example, we want it to be zero copy, concurrency, and provide parallelism. This is something that we don't provide today, but hopefully in the future we will. And below you have a diagram because you can take Mesa and then you can compile it into different targets. You can basically, you should be able to embed it into other types of platforms. Okay, so that was it. So now Manta. Manta is a CLI for Mesa. With Manta, we also want to learn about software-defined infrastructure to build a tool where people could interact with CSM and then extend the capabilities of the tools that Cray already provided. Hopefully, using Manta should be easy. And we also want Manta to be portable and script friendly. So you could use it under your CI/CD pipelines if you want. And portable means we're not portable today, but hopefully in the future, if someone wants to operate in Alps, ideally, I would like to just be able to say, this is the binary you need to use, this is the CLI you need to use, this is the link with the documentation, and then just start working. So Manta don't just, another goal of Manta is not just dealing with CSM. We also are working into introduce new features like something like we call multi-site management. In this case, CSCS is currently having multiple instances of HP Cray EX machines. And for us, that will be that we need a way in order to interact to all of them easily. So Manta, you can do this, which means you can have Alps cluster at CSCS in Lugano, another Alps cluster in EPFL. And another goal of Manta is to reduce this friction. So you can work on each cluster easily independently on the location where it sits. Okay, now the configuration. If you want to use Manta, you need to have VPN access. You don't need VPN access if you're in the office, but if you are outside, you need VPN access. You need HTTPS proxy to be able to access the ports of CSM, Kubernetes, etc. Alternatively, you can have like people from PSI, they have a VM here at CSCS that they use. We install Manta there, and then they use that as a proxy. Manta will give you access to is what we call it an aggregator. So it talks to CSM, it talks to Kubernetes, it talks to the Git, which is the Git repo of Alps. It talks to a HashiCorp instance for secret management. What else do you need? You need a configuration file, which should look like the one you have on the right. A public certificate in order for Manta to trust the CSM is talking to. And that's it. Okay, how are we going with time?
You are perfect on time.
Okay, good. So I'm gonna stop sharing this and I'm gonna share my terminal. Okay, so the first thing I'm gonna do is, I might need to go, well, it doesn't matter. So the first thing I'm gonna do is to show the configuration. So here I can see the sites I have access to. At the moment, I have configured Alps and pre-Alps. The current site I'm talking to is Alps, and these are the clusters that I have available. We can control the cluster each user has access through Keycloak. Okay, so right now I don't have visibility to all the clusters we have, only to these ones. Okay, so now we can do things. How can we do this? So let's say I want to work on Adula, and then I can do manta get configuration of the cluster. Well, no. First of all, manta has a help, okay? So some commands are better explained than others. This is a work in progress. Also, manta keeps changing. We ensure backward compatibility across major versions, okay? So for example, if you do manta apply node, you could see that these commands have been deprecated, okay? And instead, it's asking you to use manta power on, manta power off, or manta power reset. That doesn't mean that it doesn't work, still works, but probably on manta version 2, this will disappear. Probably. We don't have a hard rule on this, it depends, but I would like to remove deprecated things on every major version. So, okay, so now manta get cluster help, okay? This is the help of the cluster, and I want the HSN groups Adula and give me, no, get cluster, no, get configuration. The configuration of Adula. Okay, so tell me, this still looks okay?
Yeah.
Okay, good.
Yes.
Some commands, because it won't fit on the screen, will look ugly, okay? Sorry for that. So, okay, so here we have all the configurations that I have for the Adula cluster. When you list the configuration, you can see the name, the last time they were updated, and all the layers the configuration has with the commit ID. Remember, each one of these layers is basically a pointer to a Git repository with an Ansible script. If you tell Manta you want a specific configuration, like if I put -n means for name, that means I only want one, it will do a little bit more. It will go to the Git repository of Alps, and it will also fetch information like the date when this commit was made and who did it. Okay, this is useful because sometimes you use, most of the times we run Ansible scripts that are not ours. And if something breaks, this might be the person to talk to in order to understand what has changed and discuss about your problem. Another thing we can do is manta get, by the way, Manta has synonyms, so you can write get or you can write just G. So for example, you can do the same sessions, Adula. This is gonna tell you all the session. I'm gonna make it probably that looks too small. Okay. But I'm gonna make it bigger, but I just want to show you the columns. So on the leftmost side, you have the session name. Next to it, you have the configuration name, which is the configuration used for this session. You have the start time of this session job, different Ansible parameters, the status, if the job was completed or not, or is running, and then if it was succeeded or it failed. The target definition, you can check if the target definition here, you can see if it's an image or if it's dynamic. Image means this session is building an image. Dynamic means this session is configuring a machine. The target, so you can see if the image or the configuration of the nodes on which node is it running or which SSM group. And at the end, if you build an image, you should have the image ID. Okay, so that's basically it. So now this is the basic. Now what I'm gonna do is I'm gonna make some changes into a cluster here on live and see how it goes. So I want to jump to the clusters, and here we have a test layer. And this is a CFS layer, okay? I use it for testing. It's called test layer, and it's an Ansible script which does very little. Installs Nginx, then starts Nginx, and then it creates a folder. Very simple. One thing to mention here is that I have some conditionals on the tasks because I want to target some tasks to be run while it's building the image. Other tasks needs to be run while configuring the node. So the engine is going to be installed building the image. It's going to start it building the image, which doesn't matter. It's just an example. And at the end, the folder is going to be, this folder is going to be created while configuring the node. So I'm going to just do something. Okay. So I have this, I make a change. Now I'm going to commit my changes. Okay, git push. Okay, now what is happening is, you see here, this is my user face Git repository. This is not the one from Alps. Okay, so I push into git.cscs.ch, and what is going to happen is, and this repo has a pipeline here, has this GitLab CI.yaml. It's not showing here. So, okay, so it's a module that is going to use a different pipeline, but the only thing it does is a git pull to Shasta, okay? Basically, this is what it's doing. Let me quickly check the synchronization. Okay, I think we are okay. So the synchronization is done. Then in theory, these changes should have been made into the Alps Git repository. So now what we can do, we can go back to the Manta folder. And in here, I have some files, Manuel. I have 3 files. One is to build an image. This is called, sorry, I didn't mention before. This is called a SAT file. And this is a file where you can submit into CSM in order to build images, configuring nodes, rebooting nodes, etc. So here's when it makes important all the things I mentioned before. So you see here configurations. This section refers to CFS configuration. images means CFS session. So here we can see the configuration name that's going to be created. I have two layers. One is for the slingshot and the other one is for the cost. And then basically saying that they want to take this configuration here and build an image using this as my base image. And I want this image is meant to be for the Adula cluster. So this base image is an image that needs to already exist in the in Alps. Otherwise, it will fail because Ansible builds the inventory based on this. So this is one. I'm not going to run this one because this image runs the cost layer, which is very expensive, takes a lot of time. So, but I have this is another SAT file. It's the same idea. You have a configuration here, you build an image, and then additionally, you have a boss session template, okay? This configuration is much smaller than the other one. It only has one layer, which is the test layer, which is the same repo I just changed. And then the image is basically an image which already cooked using slingshot and cost. And then I'm gonna take this image and on top of that, I'm gonna run this layer and then I'm gonna create a new image, which is the one that is gonna be used by the session template because this name matches this name. And the session template is gonna take the nodes of Adula and it's gonna reboot them. And it's gonna assign this image as a boot parameter. And then it's gonna take this configuration and then it's going to finish configuring the nodes. And on top of that, it's going also to set the kernel parameters of the compute nodes. Okay, so let's do this. So you can do this with manta. You can do manta apply cluster. Let's see the head. Manta apply cluster. You set the file, which is the SAT file here, and then we can specify attack. So when you see here date, you can specify a tag like a version number or whatever. If tag is not mandatory, if you don't put it, you're gonna put just a timestamp. Okay, that's it. So file, say this sad manual image and configuration. I'm not gonna, let's put a version. Let's say version 1.0. And I think I'm missing what else? No, the cluster is in the SAT file, so that should be it. Okay. So it has created a session. This is my session, and now it's waiting for the session to finish. I'm gonna stop this because now I'm gonna show you manta get session for cluster Adula, and I want to see the last 3 sessions created, okay? And this command is just to save real estate on the screen. So you might not want to see everything. So I filtered to 3. This is the session I just created, version 1.0. The status is pending. First is gonna build an image. After the image is built, then it should reboot the image and start another CFS session to do the configuration. Let me see again. Okay, now it's running. So right now on Kubernetes in the management plane of Alps, there is somewhere there is a container running Ansible with the Ansible script that I just modified. So let's verify that. I can go to manta logs and I send the session name. And here it is. So because you remember the Ansible was very small. So the only thing it did is start the Nginx. Okay, and it's telling me it's okay, skipped 1. And that's all. There is another task. It says change to. So the second task to start Nginx also ran, but it's missing here because by default, the default configuration of Ansible in CSM, it doesn't print OK tasks, only the ones that change. Okay, so this is done. So the image, the Ansible to build the image has been finished. So the next step will be to take the root file system, create a SCSI first, and push it into S3. So if we check manta get session for Adula, and I just want to say -m because it's the most recent. So -m is the equivalent to L1. It just means give me the latest one. Okay, still running. So right now it's uploading to S3. I made a mistake. Well, I didn't make a mistake. It's fine. So while we finish this, is there any question?
I have a generic question, Manuel.
Yes, sure.
Manta is probably thought to be used as my user, right, on the management plane, or it's meant to be run as root?
That's a good question. So let's check it out. So if I do manta config and set authentication, okay. So now manta doesn't know who I am. So now if I run a command, manta get session h Adula, give me the most recent one. No. Okay. So now it's going to ask me who am I, because it needs my credentials in order to authenticate against Keycloak. So I put my credentials. Okay, there we are. And now it talks to Keycloak, it authenticates. If everything goes fine, Manta will receive the right instructions, which is the clusters I have access and a token. And that token, Manta will keep reusing the token until it gets expired.
Okay. So it is supposed to be run on my laptop at this point.
Well, it doesn't matter where you want to run it.
Okay. Okay.
It doesn't matter, really.
Okay, thank you.
No problem. Another thing is, for authentication, Manta also accepts the authentication through environment variables. So for example, if you're running on a script and obviously on a pipeline, obviously you cannot type credentials. You can get the credentials beforehand and then inject it into the container or host running Manta through environment variables. Oh, Anton has a question.
Yes, Manuel, do you hear me?
Yes.
Okay, so the question is, can you manage one cluster both with Manta and with standard Cray tools?
Yeah, of course, because they both talk to the API in order to do the same thing.
So if you have two sysadmins, one is trained to use Manta, one is trained to use Cray tools, the default one, so they can both coexist.
Yes.
Okay, thanks.
Yeah, the answer is yes. Obviously, there are things that we need to improve, like for example, messages, because Manta is trying to be a high-level abstraction. So hopefully in the future, you don't need to care about CFS. You don't need to care about sessions or images ID or both session templates. At the end of the day, the goal is to say, I want a cluster, I want a configuration, I want to build an image, I want to configure the nodes, or I want to shut down nodes. So the challenge there is the communication between Manta and the user. So if the user needs assistance from another person who doesn't use Manta to send the right message, like for example, look, I tried to create an image. This is the image failed. This is the name of the CFS session. This is the name of the CFS configuration. It was running on Kubernetes under this pod, this type of thing. So the other person has enough information to say, okay, I got it. So don't worry, leave it to me, I'm gonna check. Okay, so we have an image, it's completed, it's succeeded, and this is the image ID. Now, before I said I made a mistake, and indeed I did, because the SAT file I submitted the job had a both session template because I canceled the job. So the only thing that was created was the image. So if we see, if I now do manta get nodes Adula, this is my Adula cluster. And here we can see these are my nodes, the power state, the NID, the desired configuration is this one. This is the image used to boot the nodes, and this is the configuration used to build this image. So we can see that the image is not the same. And the reason is because the configuration is not the same. Here I'm running this timestamp, and here I have version 1. So let's continue. Now I'm gonna change my cluster because I want to use this image, and I want to configure them with the same configuration. Now, by the way, the reason I said before is because hopefully in the future we don't need to care about images, is because, you know, this image ID doesn't say anything. In reality, we should say, I want to boot the nodes with this configuration, or I want to configure the nodes using this other configuration, because the configuration is what it has, the layers, which has the commit IDs with the Ansible scripts that give you a better understanding of how your compute nodes look like. So, okay, so going back, I'm gonna use manta update in order to change the boot image and the configuration. So I'm gonna work at the HSM level, okay? You could work on nodes individually, but I'm just gonna do this more simple. So, okay, so manta update the cluster, and I want a boot image based on this configuration. And I also want the desired configuration to be the same. I don't have to, okay? You can have two different configurations, okay, if you want to, but in this case, because I merge everything to the same Ansible script, if you remember with the conditional that dictates which task runs when building the image and which tasks needs to run when configuring the image, then I'm okay in doing this. So what else do I need? Manta update HSN group, and at the end, the HSN group name. Okay, so this is gonna be for Adula. So now it's telling me, hold on, you're gonna change the boot images of the node. That means that the nodes are gonna be rebooted. All the nodes for the cluster and Adula. Do you want to continue or not? So I want to continue. If these parameters, boot image or desired configuration, they don't need to be together. You can just say, I want just to change the desired configuration and ignore the boot image. If that's the case, then Manta knows that because the image don't change, the nodes does not need to be rebooted. In that case, it's going to trigger a CFS session target dynamic, which means the Ansible script will run directly through SSH into the compute nodes. So no reboot. So, okay, so the nodes are off. Let's check again. Okay, obviously the nodes are off. And how we can, now we can see that the image, the boot configuration has changed, the desired configuration has changed, and the boot image hopefully should have changed. B07A, yeah, 06C. And 06C is this one from this session for this configuration. So we are all set, everything looks okay. Now, the nodes are hopefully booting, yes, they are on. What else can you do? So the node is booting. Now we can go to the console of the node, manta console node. I want to go to this machine. And you can do this. Right now we are not, this is not an SSH session. This is directly connected to the console of the machine. So this is similar to going to the machine room and plugging a laptop and a keyboard. And this is useful because sometimes the nodes might have hardware problems. And if that's the case, here you can identify them. Okay, so while the node is booting, it's gonna take a while. Any other question?
I have a question. So I can take some notes, but if I understand well, to fully use Manta, you need access to CSS ITEA. a login on Kcloak in a CSCS Kcloak with access to the big cluster you want to manage. And you also need a key to have access to control planes, so to Kubernetes cluster of CSCS. Is that correct?
Yes, you need the access to Gitea. You need the access to Gitea, Kubernetes, and HashiCorp Vault, and the CSM APIs. I don't know if I cover all your points, but those are basically all the system Manta talks to and needs to have access to. Do you want me to repeat them again?
I think it's so CSCS, Gitea, Kcloak, Vault, so HashiCorp Vault, and access to Kubernetes control plane with a key, which
Yeah.
is, I don't know how is this in terms of security isolated from
Okay.
other tenants or other users?
Good question. So that's the part where I mentioned at the beginning that the goal of Manta is to be portable, but we are not there yet. So, like for example, of staff at CSCS, they can run it on your laptop, but external staff, then as of today, they will need a VM that we will configure for you here at CSCS. And then you can run it from there internally.
So this is, you mentioned a few times, is work in progress. So when do you think this is going to be production ready? Do you have an estimated around?
So production ready. Honestly, I encourage people to use it. Okay. This will always be under high development as long as CSCS is still investing on it. Okay, so this is not something like, this is software. Okay, software is constantly changing. The demands of the people change. You give a software that does X, and then people wants to build X plus one. This will never change. So my message is, if you are keen to use it, use it. If you are internal from CSCS, you can use it. If you are external, you need to talk to whoever is your CSCS representative, and then we will organize it.
And one last question. Sorry, I'm kind of flooding with questions. Is there some documentation rather than the README on the Git repo I found on GitHub?
Yeah, the documentation is something that we need to work on. It's coming. It's coming. It's gonna come soon, because after this demo, we're gonna start working on the documentation.
Great. That's all from my side. Thank you very much.
You are welcome.
So quick note, Manuel. Ricardo has a question afterwards, but we're about 5 to the full hour. So depending on how much you have left of your live demo, we might want to focus more on questions at this point. That's all I wanted to say. So Ricardo, if you had a question.
Yeah, it's not a question, rather, I believe a clarification. Please, Manuel, correct me if I'm wrong, but for external user as of today, we do not, let's say, encourage the Gitea login, meaning that they will not talk to the Gitea of the machine.
No. The Gitea is managed by Manta. The users don't need to access there. What I'm saying that Manta needs to talk to Gitea. So it needs to authenticate into Gitea. That doesn't mean that the user is accessing to Gitea.
Yes. Okay. Thanks.
Sorry, I think I didn't explain properly. Thank you for raising this up. So another question, Ricardo, you still have your hands up.
No, thank
you. Okay, so now I'm on the node, I'm on the console root and access to the machine, and now let's see. Okay, so the node has booted systemctl status nginx. Has it been, okay, nginx has been installed and is running. But the folder is not there, and the folder is not there because right now the only thing we see now is the boot image. The second stage of the configuration, which is the CFS session target dynamic, has not started yet. So let's get out of here. Okay, so this is the batcher, okay? So this is the one that is configuring the node and is currently running. And it created the folder and apparently it has finished. Let's see. Okay, there it is. The folder is here. So that was, you know, a quick rush on how to configure clusters, building image your clusters in Manta. So remember, the process will be, you have your Git repo with your Ansibles, you modify them, you push them, they get synchronized with Alps, and then from there, you submit the jobs to build the image, then you reboot the nodes, and then you finish the configuration. That is basically it. Now, you can do more things with Manta, but I'm not going to extend it more because those are like small things depending on how you need the system to work with, but basically it. And also you could do manta config set site, and then, for example, you could do, sorry, I forgot another thing. So another interesting thing is you can check the hardware components of a cluster. So you could do, give me the hardware components of cluster Adula. And here it's telling me the hardware that Adula has. So these are my compute nodes. This is the memory. I have 16 DIMMs of 32 gig. I have 2 AMD EPIC 7742 x86 processors, and I have one 200 gigabit Slingshot 11 network interface. So that's another thing you can do, which is check the hardware of your cluster. And here, sometimes you might have a node that is running, but hardware is failing. So here you can see, if you know that this machine should have 16 DIMMs, but it only has, I don't know, 10, then you know that 6 of them, even if the node is running, you know that some memories are faulty. So this is another extension, like, for example, hopefully in the future, we should be able to calculate profiles of machines based on the hardware we have, and then query them every X amount of seconds, compare it with the state they should be. And then if it doesn't match, then we know there is a hardware problem, because here we're quantifying the hardware by type. We can say, okay, so these DIMMs are failing, this CPU are failing, and also you can do output JSON. And then it will tell you the X name all the way till the hardware component. And then based on this, you can go to HP and say, this specific NIC is failing, or this specific CPU is failing, etc.
All right. So we're at the full hour. We've got 2 more hands up. I think we can do those questions still. Andreas was first.
Yeah. So I was wondering, probably not a Manta question, but how do you decide what should go on the configuration stage and what should go in the image building stage? Because it seemed like things can go in either stage.
Simple rule is you will not configure a network, a NIC, an IP, or mount a file system while building the image. That's the simplest way to put it. Other than that, it's up to you. Obviously, you want to compile and put install binaries as much as you can to the image, okay? Because installation takes time. If it's already in the image, then you don't need to install the same thing over and over again across multiple nodes. That saves
Right.
you time. But the reality is, it's, technically speaking, it's up to you.
Okay. So yeah, thanks.
Yes, Manuel. So regarding your last piece of demonstration, so where you extract information about clusters, so it's super valuable. But you talked about authentication. So can read-only operations be done without authentication?
No, at the moment, every operation needs to be authenticated. At the
Do
moment.
you envision that like engineers at CSS can get read-only operations?
I have no
Also,
problem. I mean, technically speaking, if you can create a JW token on CSM that lasts 5 years, for example, and then put it into a pipeline and give it to someone and then use that token all the time, as long as it doesn't expire, then you can use it, that on the authentication part. Then on the read-only section, that will need more work, but yes, it's
yeah,
possible.
you see, so because read-write is dangerous. You don't want to give read-write access to everyone, but read-only access is super valuable to many people.
Yeah, that's right. But yes, at the moment, we are minimizing the impact by restricting which cluster the user has access. So we assume that the user is a cluster operator. So, basic things a cluster operator will need is to run their Ansibles against their cluster. So, but yeah, I also see your point that maybe someone just want to check stuff. I don't know. This is an open discussion. Maybe if you only want to read, I don't know, maybe wouldn't it be better to use Elasticsearch? I'm just asking. I don't know.
Me neither. So it's just a open question. Thanks.
Yeah, welcome.
All right. I think unless there's one final very, very quick question, you can raise your hand now quickly before I finish the meeting. Seems like there are no more hands. In that case, Manuel, thanks a lot for the presentation. That was really interesting, even for someone who's not sort of sysadmin in the day job. I hope you all enjoyed it as well. I think if you have questions afterwards, I think you all know how to reach Manuel and CSCS people afterwards. The recording is also going to be available. We have to see for the non-CSCS people if we can share that or what way we can share that, but I hope we can figure that out soon afterwards. Yeah, thanks everyone for joining, and thank you, Manuel. Enjoy your afternoon.
Thank you for the opportunity.
Thank you.